Welcome to Quiet Learning. In this recording, we will slowly examine how a quartz digital clock keeps time. This is a calm, low-stimulus explanation of a common electronic system that operates continuously and quietly. There is nothing you need to do while listening. You do not need to memorize or evaluate the information. You can simply listen and rest. We will proceed carefully, one process at a time, following the internal flow from physical vibration through electronic control to visible time display. Let us begin. At the center of a quartz clock is a small piece of quartz crystal. Quartz is a naturally occurring mineral. Its structure is regular and stable. When quartz is exposed to electricity, it vibrates. This behavior is called the piezoelectric effect. The vibration is extremely consistent. It occurs at a specific frequency. In most quartz clocks, the crystal vibrates 32,768 times per second. This number is not random. It is a power of 2. This makes it easy for electronic circuits to divide the signal evenly. The crystal is sealed inside a small metal housing. This protects it from temperature change, air movement, and physical disturbance. At this stage, the clock has vibration, but no concept of time yet. Electrical oscillation. A small electrical current is applied to the quartz crystal. This current causes the crystal to flex slightly. As the crystal flexes, it generates a tiny electrical signal in return. The circuit feeds this signal back into the crystal. This creates a feedback loop. The result is oscillation. The crystal vibrates continuously, at the same frequency, second after second. This oscillation forms the clock's reference signal. It is steady. It is predictable. It is repeatable. This stability is why quartz clocks are far more accurate than purely mechanical ones. Frequency division. The raw signal from the crystal is far too fast to represent time directly. 32,000 vibrations per second must be reduced to something useful. This is done using a series of digital counters inside an integrated circuit. Each counter divides the frequency by 2. The signal is halved, then halved again, and again. After 15 divisions, the signal reaches 1 pulse per second. This pulse is the electronic definition of 1 second. It is regular. It is stable. It does not drift easily. At this point, time becomes countable. Time counting logic. The 1-second pulses are sent into timing logic. This logic counts seconds. After 60 pulses, 1 minute is recorded. After 60 minutes, 1 hour advances. These values are stored in simple digital registers. The circuit keeps track of hours, minutes, and seconds continuously. This process does not pause. Even when the display is idle, the internal counting continues. The clock is always working quietly. The display system. The stored time values are sent to the display driver. In a digital clock, this is usually a liquid crystal display, or LCD. The display does not produce light. Instead,
It controls how light passes through each segment. Electrical signals activate specific areas, forming numbers. Only the necessary segments are powered at any moment. This keeps energy use low. The display updates smoothly, once per second. The change is subtle, but precise.
Power management. Quartz clocks operate on very little power. Most use a small battery. The circuitry is designed to consume microamps of current. The crystal requires very little energy to oscillate. The display only changes when necessary. As a result, a single battery can power a clock for months or years. The system is efficient by design. Accuracy and drift. Quartz clocks are accurate, but not perfect. Temperature changes can slightly alter the crystal's vibration. Over long periods, this causes minor drift. Most clocks gain or lose only a few seconds per month. For everyday use, this level of accuracy is more than sufficient. Some systems add temperature compensation to reduce drift further. Continuous operation. Once powered, a quartz clock does not stop unless interrupted. The crystal vibrates, the counters divide, the registers update, the display refreshes. This loop repeats, second after second. No awareness, no intention, just the repetition of the process. This has been a slow explanation of how a quartz digital clock works, from physical vibration to electronic division to visible timekeeping. A simple system built on stability and repetition. Quiet, reliable, continuous. Thank you for listening. This is Quiet Learning.